Product rule, multiplication becomes addition.
Quotient rule, division becomes minus.
Power rule, exponent drops behind.
Now move on to the reciprocal rule. Log 1 over a is equal to minus log a. So if a is equals to 8, for instance, so log 1 over 8, this will automatically leave you minus log 8 all in the same base x. So log 1 over 8 equals minus log 8. Then this, note that the log of 1 is 0. So log a raised to power 0 equals to 1. Remember, anything raised to power 0 is 1. Log a of 1 is always 0. Applying this, 10 raised to power 0 equals to 1. Then log base. Log of a base is 1. The log of a base is 1. For instance, log of a base is 1. Remember, just like the trick to remember this is just like you're cancelling this. As if you're cancelling this, you have, 0, like you're saying a cancel a is 1. But in the real sense, let's practicalize this. So that means that logarithm to the base of 7 of 7 is automatically 1. That means 7 raised to power 1 is equals to 7. Remember that? 7 raised to power 1 is equals to 7. Remember, this is the argument, this is the base, and this is the exponent or logarithm. A negative argument is impossible, so let's say log minus 4 is impossible. Then you have the exponential, which is log inverse. How does this work? Rewriting this is the same thing as dropping this down and bringing this a at the normal position. X will remain as a power and x will remain here. Let's exemplify. So rewriting this, you have this. Writing this, you have this. What we just did, we brought down log a, then swap this a to the position of the normal log. This is a power. This is a power. So you can say, I repeat, log a or log origin to the base a of x, but this is a raised to power. So you drop this logarithm to base a, it has come down, then you transfer this to the x position and you change this x a power. Change this x to a power, so it becomes log a of a s equals to x. And of course, you know this rule, just as you know. The logarithm of a base is 1. Logarithm of base of a, okay, this as a whole is supposed to give you 1. Look at it here. Okay, equals 1. This is 7 equals 1. So this is equals to 1. But before we do that, you know that when you have a raised to power, it becomes x. This power drops down. It becomes x log a. Right? We say this will give us x. How will it give us x? By the time this converts to 1, logarithm of a base, log a of a is 1. It becomes x times 1. It gives us x. Applying this practically equals to 5. If you want to apply this practically, just like I said, you drop down this. It becomes log 3 and then 3 swaps. This 3 swaps. The power remains. This is 5 raised to the power 5. Then they say it equals 5. How is it equal to 5? Remember that 3 raised to the power 5 is the same thing as you drop the power. 5 log 3 of base 3. We have 5, this 5 dropping down, log base 3 of 3. And then we know that logarithm of a base is 1. So therefore 5 times 1 is equals to 5. 5 times 1 is 5. Why is this 1? Logarithm of a base. Logarithm of base 3 of 3 gives you 1, and 5 times 1 is 5.